We'll go over 3 sensitivity analysis questions that would be similar to something you might see on assignment 24 and discuss a little bit of the implications of this kind of analysis. So the 3 questions are written here in my file, but they're the type of questions you may see in Canvas. And I've got my model here open. This is the aggregate planning or sales and operational planning model for product A. You may see some of these type of questions about either product A or product C on the assignment. So the first question says that for the product A aggregate plan, when implementing an inventory buffer of 50 units each month and a production capacity buffer of 150 units each month, it wants to know the minimum total cost. So if you've set up the model as in the tutorial, you would simply need to put 50 in for the assumption of minimum inventory buffer and 150 in for the minimum production capacity buffer. Of course, I have solver constraints now that ensure that ending inventory will be greater than 50. That's in solver. And that the excess capacity will be greater than 150. Now that I've entered these values, I need to resolve the model. First, I'm going to put this at 0, just to make sure I had the correct original model. So here's the original total cost. And for 50 and 150 as the inventory and capacity buffers, the total cost is $1,647,178. It's clearly much more expensive to maintain these inventory and capacity buffers. A company would want to do this in order to be able to react quickly to increases in demand. And as we're going to see in a couple of assignments, this can be advantageous, and the cost of maintaining these buffers can be worth the benefit that you get in the case where you can react to changing demand. And you read an article by Barrett and Eagle on supply chain agility that emphasizes this point. Okay, for any of these questions on the assignment, the assumption is that each one of these changes is an individual change from the original model. So I'm going to take the inventory buffers out and go ahead and resolve. And now I've got the original model. The other thing that you might want to do, 2 things, is I'm going to go ahead and just copy this original set of assumptions and maybe out to the right. And I think I will just paste the values. Okay, and so I've got those original assumptions if I ever need to go back, because these questions are going to involve changing some of the assumptions. So question number 2 says, for the product A aggregate plan, suppose the utilization rate improves by 5% in each month. The new optimal solution has total cost that decreases by what percentage? So what I would like to do first to answer this type of question is go down and record some of the original results. Mainly these 2. I'm going to go ahead and copy the original total cost and unit cost, and I'm just going to paste the values of those. And I've got it labeled as original so that we can easily measure changes from those original values. So utilization is an assumption in this model that captures the fact that there are non-productive hours that we have to pay employees for. Some of these are legitimate things like breaks that they would be paid for. Some just account for the fact that sometimes employees are doing things that are not directly producing output as specified by our labor productivity assumption. So the question is, what if this improves by 5% each month? An improvement in utilization would clearly be an increase. So what I'll do here is just take the 80%, which is the original assumption, and multiply it by 1.05. That would be a 5% improvement in utilization. And I'll need to copy that. What I'll do, I believe, is just reference the first one and copy it out. And this is just a trick. If you want to copy this over for all the months in the model, and you just reference this number, and then copy that formula over, now you can just change things in this one cell. So there's a 5% improvement in utilization. And now I need to resolve the model. And we can see that the total cost has decreased. And the question involved total cost. By what percentage did the total cost decrease? So I'll calculate the decrease. The decrease was $61,201. To measure the percentage decrease, we would take the change and divide it by the original total cost. So this is a change. In this case, we know it's a decrease of about 3.88% in total cost. So the answer is that this is a 3.88% decrease. Keep in mind, I'm using my product A model, and some of these questions you may get are for the product C model on the assignment, but they'll work the same way. Okay, now I've got one more question to go over, and it involves labor productivity. I want to go back and just change the utilization, though, back to 0.8 because that was our original model. And I'm going to resolve. Okay, and go back to the original, so our information here about the changes is reset. It doesn't mean, of course, you couldn't investigate what happened when two assumptions changed at the same time. But here we're just interested in one change at a time. So for product A aggregate plan, suppose the labor productivity improves by 8% in each month. New optimal total solution has a total cost that decreases by what percentage? Labor productivity here is stated in units per hour, so an improvement would clearly be an increase in the number of units that our workers are producing per hour. So I'll take the old 0.5 units and multiply it by 1.08, and we'll get an 8% improvement. I'll use the same trick here to just copy this across. Okay, and click Solve. And we can see that there's a significant change. So we're again here are the originals. The change is just measured at the original minus the total. We do need to know that it's a decrease in this case. And it wouldn't be wrong to state this percentage change with a negative sign. And I think the Canvas solution would allow you to do it either way. But here, since I know it's a decrease, I'm just calculating the percentage. So it's a change of 95,649. If we divide this change by the original amount, you can see that it's about a 6.1% decrease in total cost. This type of analysis is pointing to improvements that we might be able to make in order to save cost for the company. It's likely that if we wanted to increase something like labor productivity, we might have to make some investments in training or equipment to do so. But if we can do that, we have now a tool where we can compare the cost of the improvements to the benefit that we would get in terms of saving cost in our production. This should help you answer similar questions to these on the assignment 24.